Introduction. Differentiation is a method used to compute the rate of change of a function with respect to its input x. This rate of change it is known as the derivative of with respect to. The first derivative of a function y equal to f(x) is unique and unique to an infinitesimally small change in y and define an infinitesimally small change in x. It is defined by dx divided to dx equal to lim h2o in bracket f in bracket x plus h minus f in bracket x divided h. The process of finding the derivative by taking this limit is known as differentiation from first principles. In practice, it is often not convenient to use this method. The derivative of many functions can be found using standard derivative in conjunction with rules such as the chain rule, product rule, and continuum rule.
Application of differentiation in real life. First is the medical imaging and differentiation. Medical imaging technique such as magnetic resonance imaging, MRI, computed tomography, CT, and positron emission tomography, PET, produce detailed image of internal body structure. This image provides vital information for diagnosing disease, planning treatment, and monitoring patient progress. However, raw image data from these scans can be complex and challenging to interpret directly. The second is the role of differentiation. This is where the differentiation comes into play. By applying differentiation to medical image, physician can extract additional valuable information about the body structure and function. For example, the gradient of pixel intensity in an MRI or CT scan represents the rate of change in tissue density, which aids in identifying abnormal growth, tumor, and anomalies. Moreover, in functional imaging, studies like PET scans, differentiation allows medical professionals to analyze the rate of change of radiotracer concentration, enabling them to pick. And this is the example of application of differentiation in real life, which is wave. From the long wave, from radio wave to gamma rays, which have a really short wave. And this shows the differentiation of waves from long to short wave.
Okay, for question A, use the differentiation to find expression for dx dy. So the answer is y equal to 2x power of 3 minus 3x power of 2. And the dx dy is equal 6x power of 2 minus 6x. For solution question number 2, 6x power of 2 minus 6x equal to 0. And then 6x in the bracket of x minus 1 is 0. So x is 0, x1 is 0 and x2 is 1. So when x equal to 0, y equal to 2 times 0 and 3 times 0. So 0 is the answer. So when x equal to 1, y equal to 2 times 1 power of 3 minus 3 times 1 power of 2. So the answer is negative 1. So the stationary point are 0, 0 and 1, negative 1. So for question 3, there are 2 stationary point. For question 4, when y equal to 0, 2x power of 3 minus 3x power of 2 equal to 0. This means x power of 2 in the bracket 2x minus 3 equal to 0. So x1 is 0 and x2 is 1.5 or 3 over 2. So the x-intercept point are 0, 0 and 1.5, 0. So when x equal to 0, y equal to 2 times 0 power of 3 minus 3 times 0 power of 2. So the answer is 0. So the y-intercept point is 0, 0. So for question number 5, the nation pula. So for question number 5, the nature of any stationary point d power of 2y over dx power of 2 equal to x minus 6. So when x is 0, d power of 2y over dx power of 2 equal 12 times 0 minus 6. So the answer is negative 6 is lower than 0. So the point is 0, 0 is the maximum. So when x equal to 1, d power of 2y over dx power of 2 equal 12 times 1 minus 6. So the answer is 6 is bigger than 0. So the point is 1, negative 1 is the minimum point. So for the question 6, these are the graph after we plot the point. So the first point is located at 0, 0. And then the second point is located at 1, negative 1. And the last point is located at 1.5, 0.
Question: use differentiation to find expression for dy dx. We need to differentiate y equal to x square x cube minus 6x square plus 12, and it will be 3x square minus 12x. For the question 2, find the coordinate of any stationary point on the curve at stationary point dy over dx equal to 0. What we have to do in this question, we're going to find 4 points, which is x1 and x2, y1 and y2. What we need to do first, we have to take the answer from the question D1, which is 3x square minus 12x, and make it equal to 0. And we will solve the problem, and we will got x1 is equal to 0. After that, we're going to find x2. What we have to do for x2 is we need to factorize the answer from the D1, and we will got 3x in the bracket x minus 4 equal to 0. So when we solve the question, we will got x2 is equal to 4. So for the y1 and y2, we need to take back the y equal to x cube minus 6x square plus 12, and we will going to replace the value of x. For y1, we need to replace the value for x is equal to 0. So y1 we will get 12. For the y2, we're going to replace the x value to 4, and what we will get for y2 is y equal to negative 20. And what we get there, the stationary point that we will got is 0, 12 and 4, negative 20. Question 3, how many stationary points does the graph have? After we solve the question from D2, we got the stationary point is 2. For the question 4, determine the x-intercept and y-intercept point. The x-intercept point is an xy with y equal to 0. So, when y equal to 0, x cubed minus 6x squared plus 12 equal to 0, we got 3x, which is x1 is 5.620, 6 to 0, x2 equal to negative 1.284, x3 equal to 1.663. The x-intercept point, so we got the x-intercept point is 3. For the y-intercept point is an xy with x equal to 0. So when x equal to 0, so y equal to we're going to take the y equal to x cubed minus 6x squared plus 2, and we will replace the x value to the 0, and we will get y equal to 12. So for the y-intercept point, we got 0, 12. For the question number 5, determine the nature of any stationary point you found in part 2. Justify your answer. So we will use d square y over dx square equal to 6 minus 12, where we got the 6x minus 12 is from the question D1, where the answer is 3x square minus 12x. We will differentiate the 3x square minus 12x, and it will be 6x minus 12. And then what we need to do when x equal to 0 is we will going to replace the x value equal to 0. So it will be d square y over dx square minus equal to 6 in the bracket 0 minus 12, and the answer is negative 18. So the point we got here is 0, 12, and its maximum point, because the answer that we got is negative 18 is smaller than 0. So that we will do x equal to 4. So what we have to do is we're going to replace 6x minus 12. We will going to replace x equal to 4. So then what we got is d square y over dx square equal to 6 in the bracket 0 minus 12. So the answer that we will got is 12. So it is more bigger than 0. Then it will be a minimum point. So the point that we got is for negative 20. For the last question, which is question 6, sketch the graph of the curve. So what we need to do here, we put the point that we got from all the question from 1 to 5, and we need to draw line from first point to the last point, and we will see in that graph we got two point, which is minimum point and maximum point. So that's it from me. Thank you.